Question 1, Part F. Find the values of x for which the absolute value of x plus 1 is less than or equal to 5. I'm going to discuss 3 different ways of solving this inequality. I'm going to go through an algebraic solution, then a graphical solution, and finally a critical points method solution. So firstly, for the algebraic solution. The absolute value of x plus 1 less than or equal to 5 can be expressed as a 3-way or a 3-sided inequality. That is, x plus 1 less than or equal to 5 and greater than or equal to negative 5. Notice that the x plus 1 is shown without the absolute value brackets. The next step is to isolate the variable x by subtracting 1 from all 3 sides of this inequality. So negative 5 minus 1 is negative 6. X plus 1 minus 1, well, the plus 1 and the minus 1 will cancel and we're left with the variable on its own. And 5 minus 1 is equal to 4. So the solution is x is greater than or equal to negative 6 and less than or equal to 4. And here is the solution shown on a number line. For the graphical solution, I'm going to draw to scale the 2 graphs y equals the absolute value of x plus 1 and y equals 5 on the same set of axes. And because the graphs are drawn to scale, I could read the solution directly off the graph. Now the graph of y equals the absolute value of x plus 1 is a V shape with the vertex sitting on the x-axis at the point x equals negative 1. And it has a y-intercept of positive 1. And we get that by substituting 0 for x in this equation here. So y is equal to the absolute value of 0 plus 1, which is 1, which is the reason why we get this y-intercept there. Notice also that the gradient on the right-hand branch of the V shape is positive 1, and the gradient on the left-hand branch of the V shape is negative 1. Now the graph of y equals 5 is a horizontal line passing through the y-axis at y equals 5. And I'm interested in the points of intersection of the graph of y equals 5 and the graph of y equals absolute value of x plus 1. And the 2 points of intersection are x equals negative 6 and x equals positive 4. Now we want the interval where the V shape is at or below the horizontal line y equals 5. And the graph of the absolute value of x plus 1 is at or below y equals 5 in between the points x equals negative 6 and positive 4, inclusive of these endpoints. Therefore, the graphical solution is x is greater than or equal to negative 6 and less than or equal to 4. For the critical points method solution, the first step is to find the critical points by solving the equation the absolute value of x plus 1 equals 5. Once we find those critical points, I'm going to test the original inequality, that is the absolute value of x plus 1 less than or equal to 5, using values around those critical points to check if that inequality is true or false for those values that we've tested. So let's find these critical points. I'm going to solve the absolute value of x plus 1 equals 5, and that gives rise to 2 cases. Case 1, x plus 1 equals 5. Subtracting 1 from both sides of the equation, we get x equals 4. And for case 2, x plus 1 is equal to negative 5. Subtracting 1 from both sides of the equation, we get x equals negative 6. And I've shown those 2 critical points on the number line here. The next step is to test the inequality by testing points around those critical points we just found. And I'm going to use x equals negative 7, which is around here. I'm going to use x equals 0, so I'm going to test a point here in between the 2 critical points. And I'm going to test x equals 5, which is around here somewhere. So testing x equals negative 7, so I'm going to substitute negative 7 into the inequality. So the absolute value of negative 7 plus 1 is equal to the absolute value of negative 6, which is equal to positive 6, which is not less than or equal to 5. Hence the inequality is false. And I've put an X there to indicate that. Testing x equals 0, the absolute value of 0 plus 1 is equal to the absolute value of 1, which is equal to 1, which is less than or equal to 5. Hence, the inequality is true, and I've indicated that with a tick here. Finally, testing x equals 5, the absolute value of 5 plus 1 is equal to the absolute value of 6, which is equal to 6, which is not less than or equal to 5. So the inequality is false for x equals 5. And I've indicated that with a cross here. So the solution lies from x equals negative 6 to x equals positive 4. So therefore, x is greater than or equal to negative 6 and less than or equal to 4.